All right. Hi, guys. We are doing 3.1b notes, and we're going to be talking about natural base E a lot today. First of all, E is just like pi. It's called a transcendental number. It never ends and it never repeats. Okay, so like pi is 3.14. And then it keeps going on and on and on. Well, E is 2.718, and then it keeps going on and on. It's not repeating, and it never ends. Okay? E is a base. So it graphs a exponential function, and f of x equals e to the x power. To graph that, you would do the same thing as before. Find some x values, plug them into your y. Okay, so e to the 0 power, anything raised to the 0 power is 1. E to the first power, well, we know e is 2.718, so that's 2.718. E to the second power. And actually, a way we can find e to the second power is if you go into your calculator and you hit second ln. That gives you e raised to the something. So e raised to the second power is 7.39. Okay, e raised to the third power is 20.09. Okay, so that's what we will put here. So this is 7.39 and this is 20.09. And if you end up graphing that, okay, 0, 1, 1, 2.718, something around there, 2, and then 7.39, something around there, 3, and then 20, which is somewhere way up there. Okay, again, it's exponential, so it's going to have that asymptote at the x-axis. And this side is going to go along the x-axis. So it's an increasing function, exponential function. Okay, we're going to be talking about a lot of application problems, and all of these have formulas that go with them. Okay, so the first formula we're going to be talking about is A equals P times 1 plus R over N raised to the N times T power. Okay? Each of these variables means something. Okay? Your A is always going to be your ending amount. Okay? Your P is called your principal amount. Okay, basically your starting point. Okay, your initial amount, your starting amount, your principal amount. Okay, R is going to be your rate. You need to make sure that your rate is always in decimal form. Do not plug a percent into R. N is going to be the number of times your money is compounded per year. And then T is the number of years. Okay? So you need to make sure that you understand how to use this, which means you need to know what each of these variables mean. Okay? And the way you differentiate this particular formula from each of the other ones that we'll be talking about today is this N right here. Number of times compounded per year. Okay, so in number 1, it says you are investing a total of $12,000 at an annual interest rate of 3.25%. How much does the amount have after 3 years with the following compounding options? Okay, A, it's compounded annually, B, it's compounded quarterly, C, it's compounded monthly. Okay, so when you compound interest, it means it's gaining interest. All right, and here it's gaining an interest rate of 3.25%. Okay, so every time it's compounded, it gains 3.25% interest. So A, it says it's compounded annually, so it gains that 3.25% interest one time per year. B, it gains it 4 times per year, and C, it gains it 12 times per year. So obviously, if it's compounded monthly, you're going to make more money because of the interest. Okay? So in this, we're looking for A. Okay? Because I want to know how much does the account have after 3 years. Okay? It wants the ending amount. So in A, B, and C, we're looking for what big A is. Our principal amount is going to be $12,000. Okay? That's how much we are investing. That's how much you're putting into the bank at the start. R, your rate, compounded at 3.25%. Okay? Don't put it in percentage form. Okay? You have to put it in as a decimal. So in order to make this a decimal, you move the decimal point 2 times to the left. So you get 0.0325. Use that, not that. Okay? And then you need T. Well, here T is equal to 3 years. Okay? All right, so So your parent function of this particular problem is going to be A equals 12,000 because that's your P, no matter if you're compounding annually, quarterly, or monthly. 0.0325 because that is your rate no matter how often you are compounding, over N times N times 3, or raised to the N times 3 power. Sorry. Okay, again, N is what's changing here. All right, so 3 is going to be the same because, again, you're compounding for 3 years. All right, so we're going to be using this function for A, B, and C. So the only thing that's changing is our N. Okay, so in A, since you're compounding annually, you're compounding once per year. So your N is going to equal 1. So your function will be 12,000 times 1 plus 0.0325 over 1 raised to the 3rd power because 3 times 1 is 3. Okay, and I got a calculator now. So go into your calculator. You can plug that right in. 12,000 times 1 plus 0.0325 divided by 1 raised to the 3rd power. So you will have $13,208.44. if you were to compound annually. Okay, B, if you're to compound quarterly. Okay, there are 4 quarters in a dollar. There are 4 seasons in a year. So N is equal to 4. Okay, if it's compounded quarterly. So we've got A equals 12,000 times 1 plus 0. 0.0325 over 4 times, raised to the 12th power, because 3 years times n, which is 4, is 12. Okay, so let's figure out what our A is here. Plug it right into your calculator again. We got 1 plus 0.0325 divided by 4 this time, raised to the 12th power. And that'll give us a little more money, okay? $13,223.73. Okay, that's if it's compounded quarterly. Compounded monthly, that is if n is equal to 12 months in a year. Okay, so your A will equal 12,000 times 1 plus 0.0325 over 12 this time, raised to the 12 times 3 power, which is 36. So if you were to plug that into your calculator, and I'm not going to do it this time, it'll give you $13,227.19. Okay, so as you can see, the more times you compound in a year, the more money you make. Not that much though, really. Okay. Okay, so let's do number 2 on the next page. It says, how long will it take for the investment in number 1, okay, in the previous problem, that problem that we just did, to double? Okay, and I'm going to use compounding monthly. Okay, I'm not going to do A, B, and C. I'm just going to use C here. Okay, because after 1, you should know how to do this. If not, come see me in office hours. Okay, so how long will it take for the investment in number 1 to double? Okay, well, in order to double, if our principal amount was 12,000, in order to double, we would end with 24,000. So we actually know our A here. Okay, and it's asking how long will it take, so we are looking for our time, T. Okay, so we have 1 plus 0.0325, that's our rate from number 1, over 12, because that's our compounding monthly, raised to the 12 times T power. Again, we are looking for T because now we're looking for how long it will take for the investment to double. How long? Time. Okay, so as you can see, we're looking for the variable in our exponent. Okay, so we're going to have to solve this a little differently. You're going to need your graphing calculator in order to do this. In order to do this in your graphing calculator, you're going to put, well, actually, before we do this, we're going to simplify it a little bit. Okay, let's simplify this a little bit. Let's divide both sides by 12,000. You don't have to do this, but it'll be easier. You will find your line a lot easier if you do this. So let's divide both sides by 12,000. These will cancel out, and you'll just be left with 1 plus 0.0325 over 12 raised to the 12 times t. And on the left side, you'll have 2. So a lot smaller numbers that you'll have to deal with on your graphing calculator. Okay, so you're going to plug 2 into your y2, and you're going to plug the right side of your equation into your y1 in your graphing calculator. Okay, so let's do that. Okay, so you'll go to your y equals. Okay, I put 2 in my y2 already. I'm going to put 1 plus 0.0325 divided by 12 raised to the 12 times t, or in this case, x power, okay, because we're going to be using x on our graphing calculator, but it means t in terms of the problem. Okay, and you're going to graph that. This graphing calculator is on my iPad, so it's going to look a little different than yours because it's a lot longer now. But as you can see, it's got a logarithmic equation. I'm sorry, a logarithmic function, that curved line, that's your y1, and then the horizontal line at y equals 2. Okay? So the way you solve this is by finding the intersection. So you'll go to second trace, go down to intersect, and you'll find your intersection, okay? And my graphing calculator finds the intersection a little different than a regular TI-84, okay? But you're going to find your intersection, follow the steps that your calculator asks, and you should get 21.36, comma 2. Okay, so again, you graph that. You got some logarithmic function, some curve, and then you got a straight line here. Okay, that was your y2, and this was your y1. Remember, this was your y1, and this was your y2. And we said your solution comes from the intersection, which we said was where is it? Oh, 23. Oh, what was it? 21.36 for mine. 2. Okay, so that means 21.36 is your answer. 21.36 years, because that is your x value, which is your t value. Okay. All right, so let's do number 1. This is in the continuously compounding interest. Okay, this is in the continuously compounding interest. And you'll know that this is continuously compounding interest because in the problem it will literally say your interest was compounded continuously. Okay, when it's compounded continuously, you will use this formula. Okay, and there's that E right there. Okay, A is your final amount. P is your principal amount. R, again, your rate in decimal form. And then T is your time again. All right? Same thing. Again, the way to know if it's compounded continuously, to use this formula, it will literally say it's compounded continuously. All right, so number 1, it says you invest $25,000 at an interest rate of 2.5%. How much will you have after 4 years if it is compounded continuously? There are those magic words for you to use the PERT equation. Okay? So your P is going to be 25,000. Your R is going to be 0.025 or 2.5%. Again, you want it as a decimal. And then your T will be 4 years. Okay? You're going to plug these into your formula, plug it into your calculator. So A equals 25,000 times E to the 0.025 times 4. Plug that right into your calculator. So 25,000 times E to the 0.025 times 4 power. And you should get $27,629.27. Okay? And that's number 1. All right. On the next page, it's doing some other applications with half-life. Please just know with half-life, your base is always 1/2. Okay, because it's decaying to half of its mass. And I know you've talked about half-life before in chemistry. You've talked about half-life before in algebra 3. Okay, so your base will be 1/2 every time you're talking about half-life. Okay? If you have any other questions, please see me during office hours.